Hello friends, in this video I am gonna tell you how to run a transient simulation in Cadence virtuoso, how to stroke the data and how to export the output data into a CSV file. So for that let me first open the Cadence virtuoso. So now I will create a new schematic. So I will just take a sinusoidal voltage source and some resistors and of course ground. Now let me give a amplitude value of let us suppose 4 volt and a frequency of 1 megahertz, and the resistors value by defaults are 1 kilo ohm each. And now let me label the nodes as V out and V in. So this is node V out and this is node V in. Now I will click on check save. Now after this I will click on launch ADEL. Now this is my ADEL window. Now we will click here, and from here you can choose whatever analysis you want to run, like transient analysis, DC analysis, AC analysis, noise analysis, and so on. So in this video I am gonna cover transient analysis, which is selected by default. So here we have to give the stop time of the transient analysis, as we have taken a sinusoidal source of 1 megahertz frequency, which means that time period is 1 microseconds. So let us suppose I take 2 microseconds as stop time. That means I will be able to see 2 clock cycles. Now accuracy, we will select here conservative and then we will click apply. Okay. So here you can see that under the analysis options you can see the transient have been enabled and the arguments are 0 to 2 micro and conservative accuracy. Now you have to select the outputs. So for that you have to click here, set up outputs. After that you have to click here from design, and then you have to just select the nodes which you want to plot, like V in, V out, and then you have to click here OK, and then again we'll go to ADL window. And now here you can see that under the output options you can see V in and V out are here. So now I'm gonna run the simulation. For that you have to click here. So here the green one is the input and the red one is the output. So as expected, this was a resistive divider network. So output will be half of the input since the resistor voltages were equal. So as expected, the input is just double of the output, or we can say the output is half of the input. So now in order to export these two data into CSV file, we will select these two using control. We can select multiple items and then we can click on any of the waveform and then right click on that and then go to send to export, and then we have to name, let us suppose I name it demo. CSV is the file type, and then save. And then we have to go to our directory Cadence project, and we can see here that demo.csv have been created. If you open it, you can see that a lot of data points have been exported to this CSV file. The first data point is 0000. Now here you can see that this is V out X, V out Y, V in X, V in Y. So hence we can see that this X field is the time field again here this is the time field, this is voltage or amplitude axis, this is amplitude axis. So starting with 0, then it have taken data at time interval 2 into 10 to the power minus 9 and the value is this. Then it have taken again at the same time instant and data is this. So you can clearly see that this is the output data and this is the input data at same time interval. So you can clearly see that output is half of input. Again, we can see when we exported this data to a CSV file, there were lot of data points. So in order to limit these data points, we use strobing. So let me show you how to do strobing. For that, let me first close all these things. So here is my ADL window. For strobing, you have to double click on transient, then you have to go to options, then output, and somewhere down you will find a strobe period here. So here you have to give the strobe periods. Basically, strobe period is the duration at which the output data points will be sampled. So let us suppose I give a strobe period of 0.25 microseconds. Apply, OK, apply, OK. Then again I will run the transient simulation. And here also you can see that the output is half of input, but you can see that it is not a sinusoidal waveform. It have become something like a triangular waveform. So this has happened just because we have given a strobe period of 0.25 microseconds. So the output data points have been taken with an interval of 0.25 microsecond. So this is the first data point at 0. Then directly it is at 0.25 microseconds, which is 250 nanoseconds. See, both are at 0.25 microseconds. Then it is at 0.25 again plus 0.25, that is 0.5 microseconds. Then 0.75 microseconds, then 1 microsecond, then 1.25 microseconds. So now if I export these files again right click, send to, export, demo with strobing, file type is CSV, save. Now let me you can see here demo with strobing.csv file have been created. If I just open it, now you can see here the data points have been limited. You can see the first data point is at time interval 0, then it will be at time interval 0 plus strobe period, which was 0.25 microsecond. So this is 0.25 micro. Then again if you add 0.25 micro to this, you will get 0.5 micro, which is this. So basically with strobing we have limited the data points in my output file to a fixed to a less number. Here the number of data points were very large because we didn't indulge the strobing here, and after strobing it with a 0.25 microsecond, we have got less number of data points here. So that's all about this video. Thank you.